Today's going to be our shortest video of the year, I believe, and the reason is because we're talking about a concept that I think in a couple of days you'll see as one of the simplest concepts in chemistry, even though it has a tendency to make chemistry students think it's more complex than it really is, and that is the concept of the mole. All right, now here is the definition of the mole. Okay, get ready for it. Wait for it. Wait for it. It is 6.02 times by 10 to the 23rd. It is simply a number. That's all it is. It's a number that means 6.02 times by 10 to the 23rd. Now, compare that to something you're familiar with. The word dozen. Dozen just means 12. So you could have a dozen donuts, that would mean 12 donuts. If you had a mole of donuts, you would have 6.02 times by 10 to the 23rd donuts. Whatever follows the word, you have this many of them. If you have a dozen cars, you have 12 cars. If you have a mole of cars, you have 6.02 times by 10 to the 23rd cars. That's all it means, nothing more. Now, you might ask, where did we come up with this exact number, this 6.02 times by 10 to the 23rd? Well, we have an answer, and here's the reason we came up with it. Because you guys remember what AMUs were. AMUs is how we measured the mass of a single atom. Okay, for example, hydrogen is about 1 AMU, and helium is about 4 AMUs. Okay, so the question is, and the problem is that when we're in the lab, we really can't measure AMUs. So we have a way of going from AMUs to something more useful. Okay. And here's how it is. We need to come up with a conversion factor because in the lab, we can't really weigh AMUs. Instead, we can weigh out grams. And here's how we do it. If we have 6.02 times by 10 to the 23rd AMUs, that would be equal to 1 gram. Okay? That's the same as saying, or let's just put this in one other phrase just for a moment. If we have a mole of AMUs, that equals 1 gram. Okay? That's really the exact same as saying 12 inches equals 1 foot. Same idea. Okay? Or a dozen inches equals 1 foot. Pretty much the exact same idea. Okay, so now let's see why this is significant. Because in chemistry, we're always going to be talking about moles of things. And here's why we find that to be very handy. Okay, if we take hydrogen, hydrogen has a mass of we're going to get the exact mass here, 0.008 AMUs. Okay, so now in the lab, we're going to say, what is the mass of 1 mole of hydrogen? Now, if we look up here, we know that 1 mole of AMUs is equal to 1 gram. So if 1 mole of AMUs is equal to 1 gram, then 1 mole of 1.008 AMUs must be equal to 1.008 grams. Same thing if I had a mass of something that was 12 AMUs, and then I say you've got a mole of that. That might be the element carbon. A mole of something that was 12 AMUs must be 12 grams. So this is actually very simple. We come up with something called, and this is what we're going to use all the time in chemistry, so just be used to the word. We come up with something called the molar mass. So the molar mass is just how many grams, how many grams something is per mole. The grams of whatever we're referring to per mole of it. Okay, so we go back to our concept here. Let's just get a couple of examples. Let's use carbon. So carbon is 12 AMUs in a single atom. So when we have a mole of it, okay, we know that the mole of something that's 1 AMU is equal to a gram. Therefore, the mole of something that's 12 AMUs must be equal to 12 grams. So then we just say the molar mass of carbon is equal to 12 grams per mole. Okay. Now look how simple this is. This gets to be really, really easy because now we can just take the average atomic mass here on any of these atoms or any of these elements, and we can simply know that if nitrogen, if the average atomic mass is 14.007, then a mole of nitrogen must be 14.007 grams per mole. So let's just put that here. So nitrogen equals 14.007 grams per mole. And it becomes so simple because all we do is we just simply take, in fact, you'll find that most people just will refer to, instead of referring to this number as the average atomic mass, they'll just refer to it as the molar mass. Okay, we can take anything on here, and you'll see how simple this is, because if we take aluminum right here, aluminum is 26.982 AMUs. Therefore, a mole of aluminum is equal to 26. We'll write it down here. Aluminum equals 26.982 grams per mole. So we could go through this all day long, but we don't even have to go through the song and dance about saying, like, for example, phosphorus. We don't have to say phosphorus is 30.974 AMUs. Therefore, a mole of it is 30.974 grams per mole. What we can do is we can just start looking at this periodic table, looking at these numbers down here, and just saying, hey, phosphorus is 30.974 grams per mole. That's its molar mass. Sulfur is 32.066 grams per mole. Chlorine is 35.4533 or 453 grams per mole. And this all goes back to that idea that 6.022 times by 10 to the 23rd AMUs is equal to 1 gram, or a mole of AMUs equals 1 gram. Therefore, a mole of something that has a mass of 32.066 AMUs is equal to 32.066 grams per mole. Okay, so that's the whole concept. And then let me tell you one other part of this that you're going to be, let's go over two other parts. So first of all, we're going to use our friendly H2O here that we always like to use because it's so familiar. Let's first of all figure out what the measure for H2O would be in AMUs. Two hydrogens. Hydrogens are, we're going to approximate here, about 1.0 AMUs. Oxygens are about 16.0 AMUs. Therefore, in AMUs, this would be 2 of these. So we got 2 times by this. Of course, plus 1 of those, that's going to equal 18 AMUs. Okay, so if water equals 18 AMUs, my question for you is, if you have a mole of that, what would that equal? So a mole of water, okay, if a mole of AMUs is equal to 1 gram, then a mole of 18 AMUs must be equal to 18 grams. So the molar mass of water, so H2O, is equal to 18 grams per mole. Okay, that's the molar mass of water. Now we could go through, we could look at quite a few different things. Let's look at CO2. And here's what you're going to do in the future is you're not even going to do that part about the AMUs. You're just going to look at the molar mass of each of these. In fact, I know these. Carbon, the molar mass is about 12.0 grams per mole. And oxygen is about 16.0 grams per mole. And so we've got 2 of those. So the complete molecule, the molar mass of the complete molecule is going to be 12 plus 2 times 16. 2 times 16 is 32 plus 12 is 44. So equals 44 grams per mole. That's the molar mass of CO2. So here's a common problem that you're going to have. If the problem says let me check that again. You have 0.5 moles of CO2. What is the mass? So this is a pretty common problem you'll see. And here's how you do it. It's not too hard. So first of all we do is we start with 0.5 moles CO2 over here. We do this little brackets thing. We say, what's our goal? We're trying to find out mass. Mass is usually in the lab measured in grams. So if it doesn't say, you can pretty much assume it's going to be grams. Can't think of too many exceptions to that. That's the most common measurement in the lab. And so we say 0.5 moles of CO2. Okay, we need a conversion factor. How many grams do we have per mole? Okay, we have, fortunately, we just found that up here. We have 44 grams of CO2 per mole of CO2. Now we can cancel this out, cancel that out. Now we already have our cancellation. All we're left with is exactly what we want. We want grams of CO2. So therefore, we take 0.5 multiplied by 44, and we're going to get 22 grams of CO2. That's the answer to this question. You have 0.5 moles of CO2. What is the mass? The mass would be 22 grams. We could work this out for any number of problems. We could say 0.25 moles, we could say 10 moles, any of those things would be fine, and we could figure out how many grams that represents. We could also go the other way around. Let's say it says we have, we have 11 grams of CO2, and we say, how many moles do we have? And that's a pretty simple problem. All we do is we take 11 grams, CO2 over here, we do this nice little brackets thing. Our answer is supposed to be in moles, so we put moles over here. And okay, now we need a conversion factor, all right? So we need to cancel out grams because we don't want grams, we want something in moles. So we're going to put grams on the bottom. Let's see what our conversion factor could be. The exact same thing. We know that our molar mass of CO2 is 44 grams per mole. So we go back down here and we say 44 grams CO2 on the bottom per 1 mole of CO2 on the top. We can cancel out 44, we can cancel out grams of CO2, and we're left with moles of CO2, which is exactly what we want. And so now all we need to do is take 11 divided by 44. So if you put that into your calculator, you'll see that 11 divided by 44 comes out to be 0.25 moles. Okay, so I think that pretty much concludes what we're going to do today. We'll catch you guys later.